Okay, let's start with problem 2. In problem 2, you have to make a histogram and then a cumulative frequency histogram. They're slightly different. Now, I've started out drawing the histogram. Now, a histogram is a display for quantitative data. It's not a bar chart. A bar chart shows counts for categories of data. Now, these separations of this quantitative data by age do look like categories, and you could consider them to be categories, but they are strictly numerical in that they are just simply ranges of ages, and the units for the numbers is ages. Anyway, from 0 to 19 there are 47 people. So I made an x-axis with 4 separations: 0 to 19, 20 to 39, 40 to 59, and 60 to 79. And I made a y-axis that goes up to 50, and the separations here are 10, 20, 30, 40, and then up here is 50, even though nothing goes up to 50. So there are 47 people that are in the 0 to 19 bin. These separations by numbers, these breakdowns of numbers are called bins. So it's pretty rough. You know, here's what 45 would be. Here's 50, so it should be right in the middle here somewhere. Here's 43. This is more like 42 and a half or whatever. Here's 31. Well, it's pretty much right on 30. And then here's 8, slightly less than 10. The thing with graphs is that they give you a visual impression of the overall shape of the data. Don't worry about how exact your measurements are with the bars or the bins or whatever. You can see from this graph, from this histogram, that the data is what we call skewed right. That is, you have a lot of data in the lower bin and not very much data in the right bin. The data is diminishing as it goes to the right. Okay, so anyway, that's how you make a histogram. Notice that the bars are side by side, unlike a bar chart where there's separations between the bars. Also, these bars, if you will, are numerically connected to each other. They grow sequentially, like in terms of here's 0 to 19, 20 to 39. On the other hand, if you had a bar chart that was, say, genders or eye color or political party or something like that, there isn't any numerical growth or whatever, and the sequencing of the bars could be, you know, you could have female first and then male, or if you had eye color, it wouldn't matter what order the bars were in. Here, with a histogram, which is displaying quantitative data, it clearly matters in which order the bars are. Okay, so anyway, many differences between histograms and bar charts, even though at least initially they look very much alike. Okay, so what's the deal with the cumulative? The cumulative, you take the contents of each bin and you add it to the next bin. And you're going to get a very different looking graph. So we have 47 in the first bin, the 0 to 19 bin. In the second bin there's 43. Well, with the cumulative graph, we are going to take the 47 and the 43 and we're going to add them together and to get 90. And then in the third bin, where the 31 is in this first graph, we're going to take the 90 and roll it over and add it to the 31 and make 121. And then in the last bin, where there's only 8, we're going to take the 121 that's rolled over from the 3 previous bins, add it to the 8 for 129. And we're going to make a completely different graph. Okay, and it's going to look very different. This graph is going to be skewed to the right. This graph will make using the same mechanism, the same techniques, but it will be skewed to the left. That is, it'll start small and then get bigger as it goes to the right. So let's see, this graph has got to go up to 130. I'm going to stop this for a minute. I'm going to scale this and I'm going to draw the graph, and I'll be back in a second. Okay, so here's how I've set up the graph. I have the same separation on the x-axis for the 4 bins, 0 to 19, 20 to 39. And then I've got, what, 1, 2, 3, 4, 5, 6 squares. I'm just trying to fit in the space that I have. The way you set this up on the graph paper that you have will be completely dependent upon how your graph paper is set up. In general, when you're making a graph on a piece of paper, you want to use as much space as you can. The more you spread out your graph, the easier it is to see the shape of what it is you're trying to show. Okay, so I use 3 squares going vertically for 20. It just happened to work out with the space that I have that I can show on the screen here. So I got 20, 40, 60, 80, 100, 120, 140. Note that it's not all that exact, but it will give me a good shape to show the shape of this cumulative frequency graph. So 47, where's 47? Well, here's 40 and here's 60. In the middle is 50, so 47, let me bring this line up here. So 47 is going to be right around here somewhere, right around in the middle. It's not exact, but don't worry about it. With the graph, you're trying to present an overall picture of what's going on. Now 90 will be a little bit easier. 90 is going to be, let me go up to 90. Okay, here's 80, here's 100, so 90 will be right in the middle there. Let me bring this up to meet it. It's a little hard to draw a straight line on this thing here, so let's bring this down like that. Okay, so there's 90. Now 121, that's just going to be pretty much right at 120. Okay, we'll bring this up to 120, like this. And then the last one is 129. Okay, so here's 140. So 130 is going to be right in the middle here. So 130 will be like right along like this, 129. So like this. And there we go. Okay. All right, so the cumulative frequency graph, you can see the math behind it. You simply roll over the contents of one bin to the next, and then you make a very different looking graph. Okay, so this is going to be, this will be less than 20. This is less than 40, greater than 20, greater than or equal to 20. This is less than 60, greater than or equal to 40. Okay, so anyway, so there you go, your cumulative frequency graph. Now you're going to use the same approach with the rest of the homework problems that involve making a histogram. The thing that's going to be different are the problems where they don't give you the bins. This problem was fairly easy in the sense that they gave you the bins to begin with. Now I'm going to stop this for a second, and I want to go to one of the problems in which you do not have the bins already set up for you. So let's look at problem 13, in which the histogram, you are not given bins ahead of time for setting up the histogram. So what do? Well, first of all, this is not a problem that would be given to you on the ACT or SAT exam. It's very labor intensive and time consuming. And those exams are set up for each problem to be solved in a minute or less. You get 60 problems in 60 minutes. So, but how, if you were taking a statistics class, how would you solve this? You would solve it using your calculator. Now, if you do not have a TI calculator, then you can borrow one. I'm going to show you how to do it right now. So here's how you do it. So you would hit the stat key, and the stat key automatically puts you in the edit function. You hit edit. Now in L1 stands for list 1. You have a whole bunch of lists here. You can put in like 4, 5, 6 lists, whatever. Okay. In L1, you're going to put all these distances. Now let's suppose you have a bunch of distances and they're not in ascending order. I don't know if these are or not. Let's see, 119, 24. They tend to be going up because over time performance improves. But even if they weren't in descending order, that's okay. You can put them in L1, and L1 will put them in order for you. So we got 119, and then we got 1, 2. You guys see here 1, 2, 4, 1, 2, 6, 1, 2, 9. So put them in. This is taking me a while. 1, 3, 6. Okay, now the calculator is going to do an awful lot of work for you. So, in recognition of all of the work that the calculator is doing for you, go back up to the top and check your data input. Garbage in is garbage out. Make sure you didn't make any mistakes. So 119, 124, 126, 129, 130, 130, 133, 135, 136, 137, 138, 140. Okay. So the next thing we're going to do, we're going to hit second and y equals. Now we're in stat plots. Hit enter, and we're going to hit arrow down. And this icon right here, there's 6 different icons for 6 different stat plots you can do. This one right here that looks like a histogram is the histogram. Okay. Now the list that it defaults to is L1, and that's where you put your data. If you put it in L2, then you have to go there and change it to L2. So we're going to hit enter. Okay, then you're going to hit zoom and 9. And the calculator, oops, I forgot to turn it on. See, I left it off. First thing you do is hit enter and turn it on. Okay. Now we're going to hit zoom 9, and we get our histogram. Okay, now notice that there's no markings on the x-axis and no markings on the y-axis. So how big are these bins? The calculator took your data and made your bins for you. Well, if you hit window, it shows you how big the bins are, okay? And that's X scale 4.2. Now, sometimes you're going to mess with this, sometimes not. Right now, we're just going to leave it alone. We're going to go back to the graph, hit graph, and now we're going to hit trace, and it's going to tell us, here is the min one, and it's going to tell us the min and the max of this bin, 119 and 123.2. The size of the bins is 4.2. The number of data elements in this bin is 1 right here. I hit to the right. Here's the next bin, and there's two elements in this bin. I go to the right, and here's 3, and here's 2, and here's 4, and then back to 1. Okay? So when you are given a bunch of data in which you are not told the bins ahead of time, you put the data into your calculator. You let the calculator figure out the bins for you. It makes the histogram. You describe the shape, center, and spread of the histogram based on the trace key. It'll tell you everything. And that's it. That's how you do it. If you have any questions, get back to me.